Hi everyone and welcome back to my channel in Economist. So in the previous video we have discussed what a Cartesian product is all about and we have also solved some numerical questions on that. In this video we will start with relations and we will see how Cartesian product will be useful to understand this concept, right? So let's start. You have two sets given here, set A and set B. In set A you have three elements, Shushmita, Anushka and Raima. In set B, you have two elements, Rishabh and Saurav. Suppose you know this fact that Rishabh has two sisters, namely Anushka and Raima. Also, Saurav has one sister, namely Shushmita. And we want to define a relation R is the sister of between the elements of set A and set B. Then what we will get? So I want you to focus on this particular statement is the sister of. So what we want the first element from the set A and that element or that person should be the sister of the person mentioned in set B, right? So what you can write in the ordered pair form, you will write Shushmita is the sister of Saurav, Anushka is the sister of Rishabh, and Raima is the sister of Rishabh, right? This is mentioned here. You have to write according to this additional constraint, right? So you cannot take into account all the ordered pairs. You can't write Shushmita Rishabh, Shushmita Saurav, Anushka Rishabh, Anushka Saurav, right? Right? What we used to do in the Cartesian product is that we used to take into account all the possible ordered pairs. But now, when we are introducing relation, we have some additional constraint that will guide us which of the ordered pairs should be in a particular set. So here we see that these are the three ordered pairs which satisfies this additional constraint is the sister of. So they will represent the relation. Now how to write this? The above information can be written in the form of a set R. That is simply put curly braces around these ordered pairs and this will give you the relation that is mentioned in the question, right? So what we have learned, a relation is nothing but a subset of the Cartesian product. I hope now this is clear to you why we have discussed Cartesian product beforehand. If you haven't watched this video, I would recommend you to check out that. I will give the link in the description box. So relation is nothing but a subset of the Cartesian product of the two sets, right? So in mathematical notation, we can write relation is in the form AB, where A belongs to the first set A, small b belongs to the set B, and this is something extra that A and B should be related using some additional constraint which is referred to as R. So in this particular example, R is this constraint, and we will see how these constraints might appear in other cases, right? I hope the concept of relation is now clear to you. Here are some things to note that I want you to know. First is that if R is 5, then it is called the void relation. If you don't have any ordered pairs or any elements in the set R, then it is called a void relation. If R is exactly equals to A cross B, then R is called a universal relation. If R is a relation defined from A to A, it is called the relation defined on A. So suppose you have only one set. So R can be from the set A to A as well, or R can be from the set B to B as well. It is not necessary that you should have two different sets, then only you can define a relation. A relation can be defined on the basis of only one set as well, right? And if this is the case, we will call it is the relation defined on A. And it could be that both the elements of R is same, then it is called the identity relation. So if you think that 1, 1, 2, 2, 3, 3, so the elements are the same, belonging to a particular set, then it will be called an identity relation. Okay, I hope this is clear. Now we will see two very important things. What will be the domain and the range of the relation? Let us see the example that we have considered previously. R, then what will be the domain of R? We will say the domain of R will be the first elements that is written in the relationship, right? So domain will be Shushmita, domain will be Anushka and Raima. So these three elements will be there in the domain. And what will be range? The second elements will be in the range. In this example, the range is the same as the codomain. We will talk about the distinction in the later part of the video. But here we will see that range and codomain are equal just because of the fact that all the elements in the second place has a pre-image in the domain, right? Saurabh has a pre-image in the domain Shushmita. Rishabh has a pre-image in the domain, namely Anushka, and Rishabh also has a pre-image in the domain, namely Raima. So if you want to, depict this into a diagram, what we will do, we will have a domain set, we will have a range set here. In the domain, write the elements. In the range, also write the elements. Now, if you want to depict the relationship, what you will do, we will simply do this. Shushmita and Saurabh are related, so do this. Anushka and Rishabh are related. Raima and Rishabh are also related. And write are here, right? So this diagram will now depict the relationship that you have here in the rooster form. I hope this is clear. Now let us do a review question. It says you have two sets A and B, and the relation is like this. The first element belongs to set A, the second belongs to set B, and the relation is something like this. A is divisible by B. So you have to identify the elements of A which is divisible by B. And then you have to write the elements in the rooster form, find out the domain, the range, and represent R diagrammatically. So let's see what the R set looks like. If you see here, 2 is divisible by 2. So 2 will be one of the elements. Then you have 4 and 2, right? Write 4 and 2. Then what else you have? Then you have 6, 2, right? And then you have 6 and 3. I hope that is all the ordered pairs. Let's see, 2, 4, 6, 7 and 2, 3. Yes, these are all the elements, right? Now what will be the domain of R? Domain will have 2, 4, 6. 6 is repeated twice, we will take a singular element. And what will be the range? Range will have 2 and then 3. Right? So these three questions are done. Then we need to represent R diagrammatically. So let's see how we can do this. This is the domain and this is the range. So fill up with the elements 2, 4, 6 and 2, 3, right? So write 2, 4, 6. Here you have 2 and 3. Now how will we have the relation? So here you have 2, 2, 4, 2, 6, 2 and 6, 3. So 2 is related to 2, 4 is related to 2, 6 is related to 2 and 6 is related to 3, right? And write R here. So this will represent your relation. One more quick review question. R is a relation E is greater than from A to B. Then again we have to do the same thing. Let's see what R looks like. So the element should be greater than this, right? We will start with 2. 2 is greater than 1. Then 3 is greater than 1. 3 is greater than 2. 4 is greater than 1. 4 is greater than 2. 5 is greater than 1. 5 is greater than 2. Anything else? I think no, right? Is greater than, okay. So this is the thing we have. Now we need to find out the domain of R. What will that be? Take the first elements 2, 3, 4 and 5. 2, 3, 4, 5. What will be the range? Simply 1 and 2. And if you want, you can also draw the diagram to see how they are related and all. Now the final thing that we need to discuss here is that what is the codomain of a relation and how it is different from the range. I know many students who are confused between codomain and range, so I'll try to make this concept clear to you. Let's take an example. You have A to be 1, 3, 4, 5, 7. B is like this, and the relation is 1 less than, right? And I have already written it in the rooster form. The all possible scenario is this 1, 2, 3, 4, 5, 6, and 7, 8. So if you see, the first element is 1 less than the second element. Then what will be the domain in this case? Domain is simple. It will be 1, 3, 5 and 7, right? This will be the first element that is here in the relation, right? Now what will be the range? The range, as we have discussed, will be the second element in the relation. So here 2 has a pre-image 1, 4 has a pre-image 3, 6 has a pre-image 5, 8 has a pre-image 7 in the domain, right? But what will be the codomain? Codomain will be all the elements that is present in set B. Codomain will be all the elements that is present in the set B. So if you see that in the range, we have only 4 elements, 2, 4, 6, 8. But in the codomain, we have one extra element 10, which does not have any pre-image in the domain, right? Which does not have any pre-image in the domain. So everything that is there in set B will be considered as the codomain. Only the elements which have pre-image in the domain will be considered in the range, right? I think if you see this diagram, it will be more clear to you. Here, the first set is the domain, and the second set represents the codomain, right? In the domain, as we have discussed, we have 4 elements, 1, 3, 5, and 7. But if you see here, you have 2, 4, 6, 8, and 10. All these 5 elements will be there in the codomain. This is the entire elements that are present in set B. But what will be the range? Range will be only those elements which has a pre-image in the domain. So I want you to draw the relationship. 1 and 2 are related. 3 and 4 are related. 5 and 6 are related. 7 and 8 are related. So see, every element in the range that we are considering as the range should have a pre-image in the domain, but 10 is an element which does not have anything in the domain. So 10 element will be in the codomain, but not in the range, right? So this circle inside will represent the range of the relation R, right? I hope this is clear to you. So we can say that range is basically a subset of codomain. It is possible that for some cases, range and codomain are equal, that we have seen in this example. In this particular example, that all the elements that are present in set B also has a pre-image in set A. So in this particular case, range and codomain are equal, but in other cases, they may be unequal as well. So in general, we say range is a subset of codomain. I hope this is clear to you. And this is a review question. We will do this in the next session, and then we will go into understanding what is a function, right? So stay tuned for the next lecture. I hope you find this video helpful. If you do, support us by hitting the like button. Thank you for your time.